We use numerous devices in our daily life, but when they get broken or become technically obsolete, we usually throw them away. But wait, there are often precious parts inside that you can use for your electronic projects. In this video, I show you how to give the lithium-ion batteries a new life and so save the environment and money. Let's get started. In the first step, we carefully take the appliance apart and yet can easily access the battery as one of the bigger parts. But always handle it with care. Mechanically damaging the battery can lead to fire, explosion and blow out of toxic gases. So make sure that the batteries are not fully charged and that you have no flammable items nearby. It is almost impossible to extinguish a lithium fire. After we successfully dismounted the battery, the question arises how to use it, or in other words, how to charge and discharge it. Well, let us learn some theory now. There are several types of lithium batteries, each with their respective advantages and disadvantages. In most cases, we cannot figure out with which kind of battery we have to deal in our particular case. But often the nominal voltage and capacity is printed on the cell itself, mostly 3.6 or 3.7 volt. These batteries must be charged like shown here. In the first phase, the current must be limited to the amount of the rated capacity or below. If a battery has, for example, a capacity of 1 amp per hour, the maximum charge current should be 1 amp or less. The lower the charge current is, the more charging cycles you get out of your battery and the longer lifetime it has. On the other hand, charging with less current takes longer. When the cell voltage reaches 4.2 volts, the charger must reduce the current in order not to exceed this voltage. When the current has dropped to 3% of its initial value finally, the battery is full and the charger must stop loading. Unlike other battery types, lithium batteries must not remain powered when they are fully charged. Doing so would overcharge the battery, and overcharging lithium cells can be dangerous. The battery heats up very fast in this case, so the electrolyte could boil and evaporate. The battery can also burst or catch fire. Anyway, overcharging also destroys the battery or at least dramatically shortens its life. As we just have seen, hooking the battery to voltage will go wrong. We need some circuitry that controls the charging process like I described earlier. So I came across the TP4056, which is a commonly used integrated circuit designed for this task. When it comes to discharging the battery, we have to take care that its voltage never drops below 2.5 volt. Deep discharging is also very harmful for lithium-ion batteries. So we need another circuit that disconnects the battery from the load when this happens. So I came across these tiny battery charging modules that have both a TP4056 and a protection circuit against deep discharge. Let's charge a battery now. I use an INA219 current sensor module to measure the battery voltage and current while it's charging. These modules measure currents and voltages with an accuracy of 1% or even better. The sensor module continuously sends its data to a Raspberry Pi via I2C, and there I run a Python script that continuously plots these values as a line chart. We see that the module keeps the voltage at exactly 4.2 volt by slowly reducing the charge current. When the current reaches 100 milliamps, it stops charging and the indicator LED turns blue. Per default, the TP4056 charger module starts charging with 1 amp and stops at 100 milliamp. That's okay for most lithium-ion batteries with a capacity of more than 1 amps per hour. But cells with smaller capacity must be charged with less current. In this case, you must find the so-called programming resistor on the board and exchange it by a different one. Its value is easily calculated by dividing 1200 through the desired maximum charging current. Now I'm going to discharge the battery through a bicycle bulb and log both battery voltage and the accumulated capacity. As you can see, the module cuts off the bulb as the battery voltage reaches the cutoff voltage of 2.5 volt. The script also outputs the capacity, which is not even half a watt per hour. That's much less as there is printed on the battery. So we can say that this battery is worn out, but may still be used as a power supply for a microcontroller or a UPS for a Raspberry Pi. And there is another issue that we have to think of. As we have seen before, the battery voltage of a lithium cell ranges between 2.5 and 4.2 volt. But most of our electronic gadgets need 5 volt or more. This means we have to add a boost converter to our circuit to get whatever voltage we need. Now I solder such a TP4056 lithium ion charger module and a boost converter together onto a piece of perf board, connect it with one of my old lithium ion batteries, which are still good, and yet get a small and handy power supply. And it has enough power to run my test setup with the Raspberry Pi 4B and an INA219 current sensor for almost an hour. This takes approximately 500 milliamps. Okay, that's it for now. Hope this video was interesting and helpful for you. If so, give it a thumbs up, and if you don't want to miss any of my upcoming videos, subscribe to my channel and enable notifications. And you may also consider being one of the first to support this channel through Patreon. As always, thanks for watching and see you next time.